Hey guys, so let's see, getting into section 4.4, we're looking at our sine and cosine functions, and we're going to be looking at doing some graphs on these. We'll get into kind of all of them. So the sine, cosine, tangent, we'll be doing the inverse functions as well. Common name that you'll hear for these are sinusoids or sinusoidal functions. As we'll see, a cosine function is basically a shift of a sine function. And so all of these can be traced back to sine functions. So there's just kind of the fancy name for it. These are also called periodic functions for this reason, right? It's just a pattern that goes on and on and on. And so typically we will graph, one period of a function or 2 periods of a function or whatever we're asked for. But these are periodic functions. My initial goal was to fill out this table from some trig values based on the unit circle that you recently filled out. And I don't know why the chart came out so weird when I printed this, so instead I'll kind of show you where this is coming from as we go through setting up the parent functions for our sine and cosine graphs. If you do want to reference a figure in your book, there's a good one, figure 8 on page 432 that you can take a look at that might help with some. So let's go through the parent function for our sine graph. As we look at the key points on these graphs, in order to do any of these trig functions, one full period of the graph will have 5 distinct points on that curve that we always want to note and graph. So this is what I wanted to do within that chart, but we'll do it as we fill out the graph for our sine function here. So if we look at our unit circle, keep in mind that our sine values are the y-coordinates. That's one of the things that we've been talking about. So if I look at the point 0, 0, right? So where I'm at 0 pi, 0 radians, right here, I have the y-coordinate is 0. So we're going to take that first point of 0, 0 and put that on our graph. So that's where this guy starts. If we move over to pi over 2, so we're not going to put every tiny little detailed point on here. We just want kind of the 5 main key points. So as I go around, so I'm going on the quadrants. So as I go to pi over 2, my y-coordinate is 1. As I go to pi, I get the y-coordinate of 0 again. As I go to 3 pi over 2, I'm down to -1. And as I get back to 2 pi, right, and I complete one full unit circle, I'm back to 0. So those are the points that I'm filling out as I go through this. So we saw when I hit pi over 2, I was up to +1. As you get to pi, you're back to 0. As we went down to 3 pi over 2, I was down to -1. And then as I went back to 2 pi, I'm back to 0. And that completes one full period of the graph. So our parent function for our sine graph would look like this. And again, that's just one full circle. Of course, this would keep going on left and right forever the more times you go around the circle. So if I keep doing this, right, then I just keep adding more periods to this graph, right? So when we create one full period, what we're doing is we are just taking one lap around the unit circle to get that parent function. Let's just go through some of the details for this. So the domain, obviously this goes left and right forever. There's no limit to what I can put in here for x. So we're going to write this as -infinity to +infinity. Our range on this, we can see it goes as high as 1 and as low as -1. We could write the range this way. Our period, one full period would be 2 pi units. Our amplitude. The amplitude is the distance you travel from the center or from the midline of the graph to its highest point, or from the midline to its lowest point. So from the middle, I can go as low as -1, so there's a distance of 1 unit right there. Or right here, I can see a distance of 1 unit. Our amplitude is always stated as a positive because it's a distance, right? It's the distance you go from the center as high as you can go up or as high as you can go down. So we always state the amplitude as a positive value. The x-intercepts we can see occur at 0, pi, and 2 pi. And then, of course, we get our maximum value where x is pi over 2 all the way up to positive 1. So for our max at pi over 2, where high is 1, and then, of course, the minimum occurs at 3 pi over 2 at negative 1. So those are where the max and the mins take place. So that's all the details of the parent function for a sine function. Let's do the same thing for cosine, and then we'll move on from here. So for the cosine function, we could take the same approach. If you look at the unit circle, although remember in the cosine functions, we are looking at the x-coordinates. So as I go to this one, I can see at 0 radians, so at 0 pi, our x-coordinate is positive 1. So that's why the cosine function starts at 0, 1 instead of at 0, 0, right? Because now, unlike the sine function, I'm now looking at x-coordinates, not the y-coordinates. So it would start at 0, 1, and as you start moving your way around the unit circle, at pi over 2, the x-coordinate is 0, so that's going to be the next point that we plot. As I get to pi, my x-coordinate is negative 1. At 3 pi over 2, we're at 0. And then as I complete one full circle, one full period, we are back to 0, 1. And that completes one full period for the cosine function. So we saw at pi over 2, the x-coordinate was 0. At pi, it was at negative 1. 3 pi over 2 put us back to 0. And at 2 pi, we're back up to positive 1. So that completes one full cosine function. Try to get this curve looking right as we go through. So we get our parent function for cosine looking like this. And of course, like we said, this does go on and on forever in both directions. So the domain again is going to be from negative to positive infinity. My range is still from negative 1 to positive 1. My period is still 2 pi. My amplitude is still 1, right? Because here's the midline. I can go 1 that direction, or I can go 1 that direction, but it's still an amplitude of 1. My intercepts are different, though, because now my intercepts occur at pi over 2 and 3 pi over 2. But the maximums take place where x is 0 or 2 pi. Those are where we would find the maximums. The minimum occurs in the middle at pi, right? So we see the minimum of the function right there. So one thing that we're going to notice on this, and I'll just do this to kind of point this out. So if I extended the graph, and so I let it keep on going for more periods, so what we're going to see on this is a cosine function matches the sine function with a horizontal shift of pi over 2. So here's our cosine function. If I just go to the right pi over 2 units to right there, notice we now have our sine function, right, where it starts at 0, 0. I know this one would start down and go up, but if I do go pi over 2 that way, I'm seeing more of the sine function because it starts at 0, 0. Or if I go pi over 2 that way, sorry, I'm trying to cover up the right areas for you. So it would look something like this. Again, now you're seeing our sine function again. So from the left, it's starting at 0, 0, and on the right, it's ending at 0 again, right? And so really, a cosine function is just a horizontal shift of the sine function. So let me move on for you. So in this first part, they're just going to start talking about a couple of the key features of these graphs. So on the first one, they want us to identify what the amplitude is, and then they want us to take a look at how certain things that get thrown in would affect or transform the parent function. So the amplitude is always seen as the multiplier, right? So whatever is being multiplied to our sine function, like on this one, we know the amplitude is 1 because there's nothing written there. Our parent function has a value of 1. But on this one, now my amplitude would be 1/3. And on this one, my amplitude would be 2. Remember, we always state it as a positive. The negative would cause a reflection, obviously, but it doesn't change that the amplitude is still 2, because an amplitude can go up or down. And so we always state it as a positive. So that's what we would see as the amplitude on those. And that's what's being said within our description right here. Because this number in front is being multiplied to the entire function, we would see it as affecting our graph vertically. So it's either going to be a vertical stretch or shrink, just like it was in the past with other functions. Of course, if it's a number less than 1, like a third, we're going to see this as a vertical shrink by a factor of a third. If we're going to have a number bigger than 1, like positive 2 or negative 2, then we're going to see that as a vertical stretch by a factor of 2. Right? We don't really take into account the negative because we see the negative as causing a reflection, not necessarily a stretch or shrink factor. So that's what's being described on these, so we're going to try one of those on our own. This one is going to throw in some extra info on this and include the period as well. So first things first, if we were asked about the amplitude on any of these, remember it's that number in front, so 1, 3, or positive 2 would be the amplitude. So how would these then be affected if we start throwing in numbers inside the parentheses along with our x, right? And so what we're going to see on this is this now affects us horizontally, right? Because it's attached to x, it's going to affect the graph horizontally. So when we get into stretches or shrinks horizontally, what we're talking about now is affecting the period of the graph, right? We saw in the original parent function, the one that looks like this, the period goes from 0 to 2 pi, right? It's 2 pi units. But when you start affecting the graph horizontally with a factor of 1/2, now we're going to see this effect take place on the period. So the best way to see the effects on the period of the graph is a little formula. This says our period is 2 pi over b, and b is the factor, the stretch or shrink factor that you see inside the parentheses. So we would see this as a factor of 1/2. So we're going to say it's 2 pi over 1/2. And so if we clean that up, we're just going to get 4 pi. If you want to link that back to what we've already learned on this, remember when it comes to the x's, the transformations are always the opposite of what you see. It's the opposite operation. So as this one is being divided by 2, how does that affect our period? Well, if we multiply the x's by 2, we get the new period of the graph, right? So to get the new period of 4 pi. So if you did the same thing on this one, so this one would affect us vertically, right? So the maximum would now be up at positive 2. The minimum would be at negative 2. For the maximum and minimums, we have a vertical stretch by a factor of 2. But as far as this one goes, again, this is being multiplied by 2, so our period is going to be divided by 2, right? And so we're going to take that normal period of 2 pi, and it's going to become pi. So we're getting a horizontal shrink from this guy by the factor of 2, or 1/2, I guess we should say. So if you just stick with the formula, though, 2 pi over b, our b value is 2. That's this guy. We can see that it's just pi for the new period. That negative, of course, would cause the reflection across the y-axis. That negative would cause the reflection across the x-axis. Keep it moving for you. Let's do some graphs. So when you really throw in all of the transformation issues, the new function looks something like this for sine or cosine, right? So A, B, C, and D all have an effect on these graphs. Our A value, as we've already talked about, is going to affect the amplitude. It's going to affect reflections up or down across the x-axis. B values affect the period of the graph, because it's a horizontal stretch or shrink factor. The C values affect us as a horizontal shift, left or right. And the D is our vertical shift, up or down. Right? So those are all the transformation issues that we're going to run into with these. So here's the first one that we're going to look at. So we're already kind of recognizing I got a reflection, I got the vertical stretch. I'm also going to multiply my period by 3 to get the new period on this. So when we graph these guys, we want to make sure that we graph at least one full period of the function. For the maximums and the minimums, and we'll see this as we go through the process, this is one sort of algebraic approach to identifying your maximums and your minimums. When you looked at the parent function, when we first did a sine graph or a cosine graph, they were centered on the x-axis. This is what we call the midline of the graph, is the x-axis. Well, if you move the graph up or down, that's this guy, well, the midline would also move up or down, right? And so if I look at the midline of the graph, from there, I will see my amplitude and how it's affecting my maximum and my minimum from the midline of the graph or from the center line of the graph. So let's do that with this one. You'll notice on this one has no vertical shift, right? So D is 0 on this one. So from 0, we're going to be able to go up 3 and down 3 for the maximums and the minimums, right? So my maximum should be at positive 3, and my minimum should be at negative 3. The amplitude, of course, I can get by looking at my A value. I can already tell that my amplitude is 3, but there might be times where you actually have to kind of solve for it. It could be a word problem or whatever the case might be. So one thing to consider is we can do this to figure out the amplitudes. I can take my maximum minus my minimum and then just like divide it by 2. So in this case, if I took my max minus my minimum and divide that by 2, that would be just sort of another way of figuring out what your amplitude is if you need to. The period we already talked about, 2 pi over b. So on this one, I'm going to do 2 pi over 1/3. And again, it all comes back to, like doing the opposite when you're doing with the x's. So it's dividing by 3, which means we end up multiplying by 3. So I already know it's going to become 6 pi. However, if I just stick with the formula, so 2 pi over 1/3 works out to be 6 pi. So there's going to be our period. As far as the x-intercepts, we can always get x-intercepts by plugging in 0 for y. So if I set this whole thing equal to 0, I can solve for my x-intercepts that way. But let me come back to this information after we've looked at the graph here. So the way that I approach these when I'm doing these graphs, and there might be another way that you already have for doing these graphs. I know that you looked at these some in Algebra 2, so if you have another method that you're more comfortable with, go for it. This is just the way I approach doing these graphs, is I look at my period, so in this case 6 pi. I'm going to divide that by 4 in order to tell me how often I should be making marks on the graph. So remember, we talked about in the parent function, there are 5 key points to any one graph when you do a full period. So what I'm doing, and the reason I divide it by 4 is because, and I'll show you this way. If you look at one period of the graph, right, we identified like 5 key points on there, but within that, it's broken up into 4 intervals, right? So from here to here is an interval, from there to there is an interval, from there to there is an interval. So there's 1, 2, 3, 4 intervals that this is broken up into. So what I'm doing is taking the period, dividing it by 4 to tell me how often I should be making these marks. So if you do that with the parent function, take your period, divide this by 4, and what do we get? We get pi over 2. So that tells me I should be making a point on the graph every pi over 2 units. So notice we went to 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, right? And that's how often we made marks on that graph. So I take that same approach when I'm doing these guys, and I'm going to take my 6 pi. So I just caught a mistake I made, so it's not going to be 6 pi, it's going to be 6, right? Because we're doing 2 pi over b, and our b value in this case is pi thirds. So we are actually dividing by pi thirds. So the pi's would cancel, and 2 times 3 would give us 6. So sorry, it should be 6 and not 6 pi. But nonetheless, I'm going to take my 6, my period of 6, divide that by 4. And so this tells me every 1.5 units, I should be making a mark. So, and we could go by decimals. You know, typically you'll see these as fractions, but the decimal on this would still be fine because there's no pi involved. If pi is involved, we typically will keep it as a fraction. But anyway, so I know I would start at 0, and then I'm going to go to 1.5. And then if I add another 1.5, I'm at 3. Add another 1.5. Add another 1.5. And you can see it landed me right on 6, just like we expected our full period to be. So there's our kind of our 5 values for the graph if we start at 0. And so that tells us how often we're going to be making those 5 key points. From there, we just need to start plotting those points. So I know on this, right, our typical sine function went up 1, back to 0, down 1, back to 0. Now in this case, first of all, it's not going up and down 1, it's going up and down 3, because that's my amplitude. The other issue is I have a reflection. So instead of going up 3 and back to 0, because of the negative, we're actually going to go down 3, then back to 0, and then up 3, and then back to 0. So there's our main points. I know my graph will be a little ugly. Good enough, right? So there's our graph. We can always check that, of course, if you graphed it in your calculator. One thing I would do, so if I throw that in like this, we'd want to make sure we're in radians because we're doing things in terms of pi. Here's our graph, my window. I'm going to go from 0 to 6 so that I should be able to see exactly what I'm seeing on this right now. I know my y values need to be at least from -3 to +3. I'm going to go a little bigger than that so that I make sure I see the whole graph. And hopefully we're seeing what we just did on our page. And there we go. There's our graph. As far as our x-intercepts, we can see they occurred at 0, 3, and 6. So it always helps, I think, to do those last. Increasing. We are increasing from, and look at the x values, from 1.5 to 4.5 is increasing. And then we are decreasing from 0 to 1.5 and from 4.5 to 6. And we do use brackets for those. We talked about that earlier on in the year. They're increasing and decreasing intervals. They use brackets. But that's it. So that would be it for this one. Let's jump down to this guy, give you another example. So this one comes with a horizontal shift and a vertical shift. So I kind of try to throw the kitchen sink at you with this problem so you could see everything. Let's just start out with the easy guys. For this problem, understand that the midline, the center line of this graph has now been shifted down 1 unit. So instead of it being all based on the x-axis, it's now going to be based on this as our center line. Trying to keep that straight for you. So that's now the center line of the graph, is everything's going to go from there. So our starting point will start on this line, and then it will go like up, back to that line, down, back to that line, right? So, but that's now the center line of our graph. So as far as a maximum and a minimum, well, I have an amplitude of 2, right? Which means from the center line, I will be going up 2 and down 2 from the red dotted line. So from -1, if I go up 2, I will be as high as +1. And from here, if I go down 2, I will be as low as -3. Right? So there's my maximum and my minimum. Got the amplitude of 2, so what about the period? So again, I'm going to take my B value, which is 2. I'll get to the whole factored form thing in a second when we talk about our phase shift, our horizontal shift. Our B value is 2 for this one. So for the period, we're going to do 2 pi over 2. That gives us 1 period of pi units. So in a little bit here, as we make our marks, I should get 1 full period, should be from something to something, but a total of pi units. So let's talk about this phase shift or a horizontal shift with this graph. So for this guy, here is where I would suggest doing it in factored form, because when you look at it this way, I can see that I'm going to the right pi thirds. When you view it in this form, the way that they would teach you to do it is to do your C value divided by your B value in order to see your horizontal shift. And if you did that, you would then get pi thirds. So for me, I think it's easiest just to see it in factored form, and I more clearly see that my horizontal shift is going to the right pi thirds. So I would say that is my phase shift. We do have a vertical shift going down 1. And again, I like to do the x-intercepts at the end, so we'll come back to that. Don't forget, if you ever need to solve for those, it is just like any x-intercept. You would set the whole function equal to 0. Sorry, that's not very clear. You would set the whole function equal to 0, right? And then you're solving that equation. And we'll be doing more of that equation solving later, so I wanted to make sure I at least mention that here. Okay, so everything went down 1. That's why we put the midline right there where we put it. And so we're going to be working from that line. So where do we start? Where's our starting point, right? Typically, these guys start at 0, right? Where x is 0. So on this one, everything has now been shifted to the right pi thirds. So I will be making my first mark right here at pi thirds. So what about the other 4 values, right? So remember, I'm going to start here, and I'll end here. That should be 1 full period. So what do I fill those in with? And this is where I would take my period, divide it by 4, to tell me how often I should be making marks. So from here, I'm going to add pi over 4, add pi over 4, add pi over 4, add pi over 4, right? And that's what's going to give me my remaining marks. It does make for a little bit of trouble here when I'm adding fractions where I have uncommon denominators, so I do have to deal with that. So I will think of these in terms of 12s, so I can create that common denominator. So to pi thirds, I will really be adding 3 pi over 12 to that guy. So I'm starting at, let's call that 4 pi over 12. So if I did 4 pi over 12 plus 3 pi over 12, I would be at 7 pi over 12. Plus another 3 pi over 12 puts me at 10 pi over 12. And if I just keep adding 3 pi over 12, I have 13 pi over 12 and 16 pi over 12. right? So those are the 5 key x values that we're going to be using here. And again, guys, I know there's other methods. I could have come up with the original values first and come up with those points and then added pi thirds to everything where that causes that horizontal shift. So you can go that route. Personally, I feel like this is the best route to go. So this is the way I'm going to be doing it. So from those 5 points, now I can take my typical approach here. And again, I know I'm starting on the midline. This is my center line because everything has been shifted down 1. So I'm going to start here at my first point. And now I'm going to take the typical path of a sine function where I go up 2, back to the center, down 2, back to the center. So from here, I will be going up 2 units, back to the midline, down 2 units, and back to the midline. So my graph will go something like this. So that would be 1 full period. Guys, notice from this one, like some of the ones that we've done in the past, I'm not applying making all of the original set of points and then applying my shifts, like my vertical shift and my horizontal shift, because I don't want to do 2 graphs. So I'm kind of applying those as I go. So that's why I deal with that vertical shift right off the bat and call that my center line or my midline. And then I base everything from there so that I'm not having to make multiple graphs in order to get this one. So let me move on to a couple more. And there's just, I think these last 2. Let me double check. Yeah, so we're going to do 2 more. I wanted to do 1 cosine function with you. And then this last one down here will be real short. So let me go through this one a little quicker. So again, I have my basic cosine function. And let's just keep in mind what the parent function looks like for this, right? So there's our parent function. Typically goes from 1 to -1. And so we'll be kind of working with that. So again, let's recognize on this one, the parent function was typically at 0, the x-axis. That's a positive 1 right there. So I know this whole thing is going to shift up 1. So my new midline will be right there. So that will be the center line of my graph. For a maximum and minimum, I can see that my amplitude is 1. So from here, I will be going up 1. And from here, I'll be going down 1. So my highest point should be 2. My lowest point should be 0. So there's our max and min, our period. Our b value on this one is simply 1. So 2 pi divided by 1 is 2 pi. So this one's a little more friendly in that regard. We'll do the x-intercepts at the end. Oh, you know what? That reminds me. I don't think we did those. So let's go back to this guy for just a second. Guys, on this one, because we have not worked on solving equations yet, what you would do to find x-intercepts for these guys is you would graph this function in your graphing calculator. It's obviously going to come out looking something like this one. And then from there, you're going to find the zeros of the graph. We've done this before, so remember, if you want to find the zeros of a function, this is our last one that we did. You go under Calc, choose 0, and then they're going to ask you questions like a left boundary, so go to the left of your 0, hit enter. Right boundary, go to the right of your 0 and hit enter. When it says guess, hit enter 1 more time, and then it's going to tell you what the 0 is of that graph. And so you could do that for each of your intercepts that you're looking for. We'll be solving those equations later on by hand. So back to this one. We'll do the x-intercepts at the end this time. Our horizontal shift, our b value is 1, so that makes this a little easy. We can see this is going to go left, pi thirds. So we're going to start pi thirds to the left. So remember with the cosine graph, they don't start on the midline, right? They start with the amplitude. So in this case, our amplitude is 1. So from my midline, I'm going to have to start 1 unit either above or below the midline. In your parent function, it starts 1 unit above the midline, right? It goes up first. So it would typically start here. This guy, however, is being reflected. So instead of starting 1 unit above the midline, I should be starting 1 unit below the midline. So we're actually starting at the minimum instead of starting at the maximum because of the negative that I see right there for my A value. So that's where my first point will be. Where will the next 4 go? And that's where I will take my period, divide it by 4 to see how often I should be making marks. So to this, I'm going to be adding pi over 2. Again, you have the whole common denominator issue. So let's think of this in terms of something over 6. So instead of a half pi, I'm going to be adding 3 pi over 6 to this guy. So think of that as negative 2 pi over 6. So if I did negative 2 pi over 6 plus 3 pi over 6, I will be at 1 pi over 6. And I'm just going to keep adding 3 pi over 6. So if I add 3 pi over 6 to this, I now have 4 pi over 6. Then 7 pi over 6. And 10 pi over 6. And that's enough to give me 1 full period. Guys, of course, you can reduce these, right? We can write this as 2/3. I can write this as 5/3. So we can certainly reduce. I'm just was doing that to help make it easier to get the points that we need. So anyway, I know where the x values are for where my points are going to go. So the pattern of a cosine function starts with amplitude, 0, amplitude, 0, amplitude, right? That's the pattern that this will always carry on. So I'm starting with amplitude, center line, amplitude, center line, amplitude. All right, so there's our graph. We'll give it the curve. And again, I always like to check these guys and make sure they're looking good. So let's graph this one real quick. On this one, I got 1 minus my cosine, x plus pi thirds. So it looks like this. And in this one, let's adjust our window. I'm going to go from negative pi thirds up to 10 pi over 6, or you could say 5 pi over 3. So that way, what I see on my screen should match what I see on my paper. That's why I'm picking that window. And then as far as my min and max, again, just make sure I'm at least from 0 to 2, which I'm already good enough. So let's go with that and hit graph. We are looking pretty good. Again, if you want to calculate the intercepts on this graph, this is where you would go under calc, choose 0, and just pick one. You have 2 of them. Although, never mind, we don't even need to do that on this one because we already got them on our paper. So these guys happen to be already at our zeros, so I already know my intercepts are negative pi over 3 and 5 pi over 3. Last thing I want to show you in the video, sorry, I know this is a long one, but trig graphs kind of go that way. But I wanted to give you a lot of examples to help you with homework. So they're giving me the maximum point of this graph at 5 pi, comma 4. Yep, that's a 4. Is this a sine graph or a cosine graph? And then we're going to solve to figure out what our A and B values are. So as I look at this one, Guys, notice the way that these are written, there is no room for a horizontal shift. Right? You don't see like a D value in this, so it's got to be just closer to a parent function graph. There's no horizontal shift, or sorry, a C value on this one. So based on this, I can see the center line is at 0, the x-axis. There's no vertical shift either, no C or D, right? So the center line is the x-axis, and because it does not start on the x-axis, I know therefore it's a cosine graph. So it's got to be this guy. So then what would that make our A value and our B value? So let's start with the easy one first. Our A value represents the amplitude of the graph. I can see from the midline it went up 4. So just based on that, I can see that A is, oh, you know what, I better be careful on this one. The A value, because it started at -4 and then went to +4, right? This is like the reflection of our parent function for a cosine graph. So our A value in this one is -4. So guys, do understand that your A value can be negative. If they said, what's your amplitude? The amplitude we would say is +4. It's always positive. But the A value itself, represented in the function, can be a negative, right? That tells us there was a reflection. So that's our A value. Our B value helps us with the period of the graph. So if I look at one full period of this graph, how far did it go to the right? Well, if halfway through was 5 pi, it must have gone 10 pi total for one full period. And remember the formula we've been working with, 2 pi over b, is this one. So since the period is 10 pi, we can now solve that equation to figure out what b is. So if we solve that equation, we get 1/5, and that would be our b value. Whew. And that is it for this section.